Nice. So, okay, cool. So, yeah, like I was saying before, it's kind of like starts from the beginning with installing GitHub. So you can probably not do that already. But oh, let's go. All right. So yeah, and like I mentioned before, we're gonna do GitHub first, zoom through these slides. We're gonna do some hands-on stuff with Python and GitHub. Okay. What is Git and what is the difference between Git and GitHub? Git is that it's a free and open source distributed version control system. Basically, the only important words are distributed version control system that tracks changes and is used for coordinated work. So this is like a command line interface tool. It's like some dude made Git in like 4 days, and now everyone uses it. And then GitHub is like the internet hosting platform for it. So it's like a remote repository for hosting Git files. And it has like extra features. So access control, like when you have on your team, you probably have a private repository that only a few people can access. That's kind of what GitHub provides. It also has like those things. Some of those things are not free features, but anyway, it's useful. And GitHub's not the only one. You can use Git with a lot of different online internet remote repositories. There's like Bitbucket, there's GitLab, a lot of no names. Most people use GitHub or like their own version. Like Amazon has their own version. Yeah, what do you use them for? So the idea is you're working on separate parts of the project at the same time. So if you want, let's say you're making a website, one person will make the home page while someone else is working on the login page. And you don't want to change the code simultaneously. You can't really change the code simultaneously anyway. It's kind of, there are some tools that let you do that, but you don't want to do that. You want to work on them separately, and then when they're finished, merge them together so you have the home page and the login page at the same time. It's also a good way of like keeping a certain branch that's like fully working. Hello? So like a stable version or production version of your branch. This is typically the mainline branch. It's also called like the main branch or the master branch. They stopped using the word master, so it's normally main. But some things, this is literally, you can say it, it's very arbitrary, you can call it anything. Some people have like a stable branch versus a main branch. Stable is like, they know it's been working for years. Main is like what they're currently updating. You can kind of see that. Quick side note. We're going to Python. This is a programming language. It's code, but the way they write it, it is code itself. But you can see there's different versions. And to host like different versions, these probably have their own like repositories somewhere where they work on it. And they work only on the main version. But there's also a thing called like long-term stable. Anyway, long-term stable means they're updating it, but it's an older version. That would be like a stable branch. All right. And then sharing and testing code is like the biggest advantage of Git. So being able to check out someone's branch and run it on your own laptop or your own computer, seeing how the code works on your own environment, that's the biggest advantage. And then pull requests is how you like review line by line someone's code. And let's say you push a change and it's completely breaking your project. You don't have to like delete all the lines personally. You can just revert your commit, and then it's like it takes 5 minutes and you fix your project. All right, so we kind of went over this, but if you haven't installed Git, you should do that in the next few minutes. I put this in the Slack as well, but this is the command line tool that other things rely on. And then I like GitHub Desktop. I'll show you what that looks like real quick. It's just oh, it's not working. It'll let you see your changes. If you add something, delete something, it goes line by line. You can kind of do the same thing in the command line version, but for large projects, I find GitHub Desktop's a lot better. All right. These are the key concepts that, well, if you're going to use Git, these are the key concepts. There's more concepts, but this is what you're going to use. So branches. So branches, kind of like in that diagram up there, being blocked. So the idea is you have your main branch, that's your stable production version. And then you can branch off of that, make your own feature with your work. And then someone else at the same time can branch off somewhere else and do their own work. And then you merge it all back into main. So you're not breaking the main production version while you're working on it. And you're able to work on it at the same time as other people. So yeah, they're arbitrary, so you can do it person by person. That's kind of what I do in my team, like Drew development branch or Sarah development branch. Or you could do by feature. So I work in the home page, I'm going to put it on the home page branch. Yeah, so the idea is to keep all of the features that you're working on out of the main production branch until it's ready. So we're assuming in that little diagram, let's say they were working on different parts of the app. So I'm working on the home page, someone else is working on the login page. If we merge that into main, there's no conflicts. There are two separate pages, none of the code is shared between the two. But if we were working on the same thing and we did different changes on the same parts of the code, that's when conflicts occur. So kind of you're trying to avoid changing the same code, but if it does happen, we'll get into like how you address that. All right, so example of how our team does branches. So like there's the mainline branch, different people have different branches. I've kind of just kept this Google VR version from 2 years ago, in case you ever want to go back to Google VR. I don't think we need to do that anymore, but for history's sake, that's why that's there. But this is our Sutron VR app. Oh, and different things you can see on this. This is the GitHub interface for branches. You can see the like under the middle column, there's like numbers and bar charts. So the number on the left means that's how many commits behind the main branch that branch is. So Vivian Dev is up to date with main, and it's actually 1 commit ahead of main. Whereas Juan Dev is 4 commits. Those are separate commits. So Juan and Vivian work in different things, but they are both based off of the main branch. Whereas Tree is 13 commits behind main, and I have 28 commits behind main. Generally, you don't want to be that far, but because stop using that branch. But yeah, you can see that's what that's showing. We'll get into pull requests later. There's other things, like delete branches from the interface. All right. So when you make changes on whatever you're doing, you'll commit and push it. Commit and push are kind of the same thing. Yeah, I'll get into the diagram in a minute, but commit and push are kind of the same thing. You're putting code from your computer onto the repository. Fetching and pulling will get any changes from like GitHub and put it on your computer. So if someone else updates your branch, that's how you update. You would fetch and pull it. So here's like a little flow chart. So you make your changes, you commit the changes, you push changes. And you'll notice you commit to a local repository and you push to a remote repository. That's a pretty good diagram of how it works. So there's 3 different branches here. So person 1 has a working copy. If they commit, it'll go to a local repository that's stored on the computer. No one has access to that until they push it to the remote repository. And there's still 3 branches on the remote repository. And other people can pull it and update. That's what that's showing. So you kind of do both at the same time, usually commit and push. Note on commits, you want to like make your commit text. So that's like telling other people what you did in that commit. So if you change a bajillion lines of code because you're implementing blockchain, you want to describe that. Actually, you probably want to divide that into separate commits, describing each individual step. But here's 2 example commits. One's pretty good, one's not so good. So Greg was allowing other screens to be accessed without off. And there's some changes, but that's a pretty descriptive description. Yeah, obviously they don't need off anymore. And Andrew Sawinski, the past ET director, it was his personal project, so can't really get into too much, but he added 12,000 additions instead of a lot of files. That's not very helpful. Because we have no idea what those files do. Some other things you can note on this interface. So you can see like how many additions and deletions there are, how many change files there are. Just on that. Yeah, and you can see like what branch you pushed it to. So Greg pushed it to master, Andrew pushed it to main. Commits, pushes, and pulls. Okay, that's the wrong title. This is merging and pull requests. So when you merge 2 branches or merge a branch into master here, okay, so when you merge any 2 branches, you can do that. It's not just in the main line. You can merge Drew dev into the main dev, and you can do that. And those changes we put together. And when you merge branch A into branch B, the changes from branch A go into branch B and not the other way around. It's a bit confusing, but it takes, honestly, this takes getting used to it, working with it. So all those changes will be put onto the target branch, and you'll have to resolve any conflicts, like we mentioned. We'll get to that in a minute. So a pull request is basically merging, like asking for you to merge 2 branches. For some reason, it's called a pull request. Like, here's what they said. They use the name pull request, blah, blah, blah. And some other tools just call the same thing as a merge request. So it's the same thing. But just think of it as merging. But with pull requests, you can comment on it. You can, your team can see what you're changing. It's kind of an extra step before you destroy everything. You're letting your team review it. So here's an example pull request. So Tree was making ocean turns more smooth. So I checked out this branch, and I noticed some bugs with it. So I commented on it on GitHub, like some bugs I found. And then based on that feedback, he did another commit, and then it was still open, but then we merged in after this changes were made and it was fixed. And so you can see under here, this is the initial commit, a comment, and the second commit. And you can invite people to review your code. That's what this reviewers thing in the top right is. If you want, if I wanted Juan to look at this specifically, he could look at it and make sure it's right. All right, so let's say you were trying to merge two branches and you have a conflict. So your initial program says print hello world, and then person A changes it on their own branch to say hello universe, and then person B says hello John. And then you try to merge those two into me. What do you do? So let's say A made it hello universe, now it's updated hello universe. B wants to merge that change. Yeah, so that's when a conflict arises. The same text of that same line was changed. And I don't think, okay. What are you gonna do on either your local repository, like on the command line or in a text editor, you'll see that there is a conflict, and we'll get into this in the hands-on section. But you can choose to either take the version from person A, take the version from person B, or manually edit it to kind of include changes from both people. But that's, if you take it from A, it's automatic, B, it's automatic. But if you want both, you have to do it manually. Yeah. And you'd have to make a new commit based on that merge or based on that conflict fix. All right. And then when you make a repository, git ignore file is super important, actually. This isn't important to like the functionality of how your repository is shared among, well, is created, I'd say. But if you're sharing it with team members, and let's say someone's working on VS Code on a Mac, and someone else is working on IntelliJ on Windows, and then someone else is working on VS Code on Windows. If you don't git ignore things, those preferences will be, let's say on your VS Code, you want dark mode, someone else wants light mode. That will be pushed to the repository. And other people will pull on your changes, and that will have light mode for that project. That's not what you want to have happen. So you would git ignore files from VS Code that are generated. Also, in cases like C++, there are files that are generated based off of source code. So that's like a .o file. Those are machine-specific binary code and are completely useless on other people's machines. So you don't want those to be on your repository. So you would git ignore all .o files. Here's an example of a git ignore for Unity. Unity is really important to have a good git ignore for it because it's a 3D game engine, so it's really big files you want to ignore. There's a lot of things there, but basically you're trying to target different words in your repository. So the top example is library spelled either capital L or lowercase l. That's an unnecessary, anything in this file won't be pushed to your repository. So down here is VS Code stuff. You don't want that, so you ignore it. For GitHub, there's lots of templates that are just publicly available. That's literally just from this official GitHub git ignore file. you would add this to the root of your repository. So let's just go. Let's open up Sutrin VR. You'll see we have a git ignore here. You'll notice there's no library folder because we're ignoring it. And anything that is in this same directory as the git ignore will be ignored. So you could have this git ignore inside of the assets folder and ignore things based off that. Or you could define it in the git ignore. So here it says asset metadata should only be ignored when the corresponding asset is also ignored. There's lots of different fancy things you can do with the selection features, but this is just the general structure of it. When you create, we'll create a repository in a minute, and you'll see how that works. All right. So if you're using the command line, you have to remember a lot more things than GitHub Desktop. These are a few of them. I kind of just put them here for future reference, but this will help you like make new branches, commit, push, stash, fetch, pull, merge. All of this is done from your terminal. So you can kind of, if you need to do this, sometimes you do need to access the command line version. You can do it just from command line. You say like, git status in your project repository, or your. So this is where the project is stored on my computer, and I'm doing git status. And you can see that's what that looks like. All right. So now we can like get into the actually doing stuff. All right. So does everyone have Python installed? If not, I posted a link on the Slack to install Python, or you can just you can Google Python install. It might take a few minutes, but yeah, we'll go into a little segue here into, we're going to do a leak code question. That's not it. Wrong one. We're going to do, that's not it. This is it. All right. So I'm going to push this to a repository, and I'm going to share the repository with you all. It's going to be a private repository, and you'll kind of just see the steps I do to create that repository and add you all. So let's go. So I'm going to GitHub. I don't like doing the command line version of this because GitHub just does it easily. I'm signed in already. That helps. And then we create a new repository. It's on the left here from the main page. And then what are we going to call this? Workshop Python. You can change your name later, so it's not super important. I'll make it public for now, just to make it easier. And then the important step when you're initializing, you don't have to do it when you initialize, but you see how you can add a git ignore here. That's what you want to do. So we're going to add this. And let's see if Python has a default one. They do. So we're going to do Python. And we'll see what that looks like in a minute. So now we made the repository. And we'll just take a quick look at the git ignore. So here's what it ignores. All these files are completely unnecessary. There's a lot of them. I did not realize that. Because Python is pretty complicated in terms of local files. So what I'm going to do, I'm going to share this with you all, and you're going to try to clone it from your Git command line or desktop. And if you need help at any point, just let me know.
Okay. I'm actually curious. If I just send out this link, are you able to work on it? I'll send it. Slack.
Try accessing that and try
Cloning it. And cloning it is making the repository available on your local machine. So you would do that on this interface. You go to code. There's a URL here. You would copy that. And there's two ways of doing this. I like using GitHub Desktop. So I'm going to go to GitHub Desktop. I'm going to go in the top left here, add clone repository. We're using a URL. Try putting it here. That's the one we just copied, and we clone it. So now, yes.
Like I know we do cloning and stuff, but is there a way to get it so that it doesn't just make like folders? Yes. Like I put it into another folder that already made. Yeah. So how did you just clone it? So I used Bash and I just did like get clone and the URL. Okay. Yeah. So the reason why it's doing that, you look at your current directory. Okay. So then if I just like, yes. So if you just put it in a new directory, sweet. Okay. Cool. And so yeah. Everything else working on that? Good.
Cool. Okay, so we cloned it. So now if you go to that folder that was just made when we cloned it, you can do that through here. If you go to repository, show and explore. So now you can see there's a hidden file there. That's all the Git stuff that it stores. You don't really need to, you should not touch that actually. You should just let that do its thing. But you can also look at the git ignore. And there it is. That's the thing we just made from the online interface. So now I'm going to push this workshop code to the remote repository. So let's see where this is right now. So it's on my desktop somewhere. So I'm gonna, because I'm not really editing the actual code right now, I'm just going to copy and paste it into the folder with the Git, like the Git repository folder. And then you will see, if we go to GitHub Desktop, now it's available to be staged. So staging is basically choosing which commits you want to commit or which changes you want to commit. So that little checkbox on the left is staging or not staging. So if I didn't want to put this change on GitHub, I would uncheck that. And it says I don't have write access to Workshop Python. Okay, so I'm going to add everyone should send their GitHub usernames in the Slack, so I can add you. I'll put it. Yeah, just put it in this thread here so not everyone is notified. Let's go. Okay. So we're going to add lots of collaborators here. So how I'm doing this, I own the repository. I think only the repository owner can do this. That's unfortunate, but I went to settings, collaborators, now I'm adding people. This is a GitHub specific thing. Like I said earlier, this is not like just Git. So I have to spend a minute on this. Wow, I can only do one person at a time. That's awesome. All right, and then you'd have to go to your email and accepting that invite. Okay, so I just did that. Now, if we fetch this, if we restart GitHub, now I have push access. So now I'm going to push this to the main branch. So yeah, I'm just going to keep, if you don't type anything here, it'll just say create workshop code.py. That's good enough for now. That's what I'm doing. So now you'll see I committed it on the bottom left here. And if you look at the history, we have create workshop.py. I committed it, but you guys can't access it. It's not on refresh. It's not on here yet because I didn't push it. So now I'm going to push it. And then we refresh that again. And now it's there. So now if you guys fetch the repository and pull it, you should be able to get that file. All right. That worked for Right. So once you're in like the repository folder, you do git fetch. That updates like what your computer sees from GitHub, and then you'll do git pull.
Fetching like super necessary. I've never done it. Like I always just pull, so I don't know. Like
So
a lot of utility.
yeah, it does it automatically sometimes, but there are weird things that happen if you don't do it. So it's always good to do it before. So sometimes, like let's say there are two pushes to the main line. Your computer sees one of the pushes, and so you pull that, and it's still one commit behind, which can cause probably pretty minor issues, but it can be weird. Everyone good? Cool. All right. So now what we're going to do, so you have that code. You all probably have seen this question, maybe. So this is where the Python workshop starts. So first thing, there's a multi-line comment and a single line comment. That's how you do it. Yeah, I like using VS Code, so that's what I'm using. You don't have to use any particular one. You do have to have Python installed to run it. So VS Code's nice once you set it up.
you can run it from the interface pretty easily, and it has autocomplete. So let's just say print hello world. And once I save that, I run it. All right, you can see down there it says hello world. Notice how if you've only used C++, that's a lot simpler than C++. We didn't have to compile, we didn't have to import anything. Yeah. All right, so right now, you guys are gonna work on that problem. And I'll give you, does everyone, can everyone see this first of all? Whenever you have it on your own computer, but does everyone know where to start with this problem? It's Tucson. If not, other people can show you how to do it once you push it to GitHub. But the things you'll need to know for this, so the input, we're using the standard input, and we're taking a space-separated list of numbers for our input, and then we're going to output the list in the format. So the answer to the question is two numbers that add to a single number. There's a slight misstatement here. You're also going to take in, so this will be line 1 and line 2 that you input will have the target number. So if we just look at LeetCode real quick and get an example. So for this first one, we would input 2, 7, 11, 15. We're shooting for 9, and we output this string that includes the brackets 0 and 1, which is indices of 2 and 7. Yeah, so that's our goal. So I've already shown you how to print things, and in order to input things, you're going to do input. Yeah, and you can store this as a variable. It'll store it as a string. So that's how you do input. So we can kind of work on this together. And as far as different, like just getting set up. So what are you guys' thoughts on how we solve this? Yes, yeah. So we're given a string of space separated integers, and we return that into a list of numbers that we can actually use. So does anyone have any ideas on how we do that? All right, so how do you do that? So we have our inline, this is our string, this will have currently 2, 7, 11, 15 as a string. Oh. So we know they're space separated. So we're going to do, there's a split function in Python, .split, and this will split the string into a list based on whatever we say it should split on. If we do no input, it'll split it by every character, but we can also put space. And now it'll make a list of strings split by spaces. So after we do this, it's now going to be 2, 7, 11, 15. And note in Python, there are no previous like Java or C++. There's no variable typing, explicit variable typing, or at least it's not required. You can do it if you want. But so inline, is now a list of strings. So we didn't have to like say inline is a list of strings. It just is. So how do you guys suppose we turn that into a list of numbers? Like what's our goal? Parse it. Yes. How do we parse it? Yes. Okay. So the way we parse it. Yes. So honestly, I'm not sure if this is the efficient way, but it's decently efficient. So we know we want a list of integers. So what we can do is we can do a for loop. We go through every number and turn it into an integer. So for I, this is how you do for loops in Python. For I in range, and then we're doing the length of inline. So what we're doing here, this is the same as like in C++ for int I equals 0, I is less than inline dot length I plus plus. And remember in C++ you need brackets. In Python, it's space. It reads your code by spacing instead of brackets. So now when I press enter after putting in a colon, that's how I said it was done with that line. Now it indented by a tab. So that's how that works. So now we're going to say inline of I equals int of I, or int of inline of I. So now we made every number or every number string into a number. All right, so what's the next step? We have a list of numbers now. So what do we do with those numbers? If we're trying to get, if we want to get the sum of 9, we want indices that add up to 9. All right. So we iterate through and we check. So we're iterating through every number, right? So there's a nice feature you can use. If you've ever used a for each in C++, Java, you can do like for each object in this list or in this iterable thing. The way you do this in Python is you just say for num, or literally anything you want to call it, inline. So now this will individually go through 2, 7, 11, 15. But we also probably want the index. So instead of individually accessing each index, which we can do for index num in enumerate inline. And that does the same thing. So now we have the number 2, 7, 11, 15. But we have 2, we have I equals 0, 7, I equals 1, like that, and so forth. So let's say we have our first number 2. How do we find if this is valid as an answer? Good question. So I should clarify, I think these numbers can be negative too. That might work. Yeah, so that's the straightforward solution. So we have 2, and we just check if we add it to 7, is that equal to 9? In this case, it is. Let's say it wasn't. We add it to 11, is that 9? No. If we have 15, is that 9? No. So how will we do this nested for loop? So we have our number, which is going to be 2. Well, we already know we want a nested for loop, so you guys have probably used the notation like J as a nested for loop, and we'll call the first one num1 actually, and the next one num2. You don't actually, there's no requirements what you call this. And we'll do the same format, enumerate, inline. But there's a problem here. This will like repeat, this will go through every single number if we did this. And we don't really want that. We just want the numbers after 2 because we've already checked everything before that. So what we can do is go back to this form. So that's the advantage of one form and another. If you need to go through everything, you can do the for each syntax. If you only want to do a subset, you can use the indices syntax. So let's change this up. So we can do for j in range. So up here, we only use 1 input. And instead we're starting from 0, we're going to the length, and we're increasing by 1. We can do with 2 input or 2 parameters, we start from I plus 1, and we're going to length of inline. So now it'll go stepwise, it'll increase by 1 every time. J will start at I plus 1 and go to length of inline. And now we're going to see what are we actually checking is num1 plus inline of j equal to, so this is how you do equals Boolean stuff, equal to target. But we forgot to get target. So we got to do another input. And we can do this in one line. We just do target up here. We said it was going to be the second input line. So target equals int. So we're just going to straight up convert it to int input. And now this will get our target of 9. So now we have this defined out here. And so for every number we're checking, is this true? And if we find an answer, we're probably going to want to just print out the answer when we're done. And you guys have probably worked with like returning things and breaking out of for loops. If you break out of this first for loop down here, it won't break out of the second one unless you do some weird syntax. So I think it'll be easier if we make this into a function. So we can short circuit it when we finish and just return the numbers we have, the answer that we have. So how do we make this into a function? Does everyone know what functions are? Okay, cool. If you don't, you'll learn. Not really, but you'll learn how to do it in Python. So we have to define it before all of our code that uses it. So we're going to do it up here and get rid of this comment. And we're going to call this, I don't know, solve to sum. So we don't have to define the input values or like what type of input values are, what type of output values are. Like I said earlier, you can do that, but you don't have to. So we're making this function. It's going to be called solve to sum. And we put our input parameters here. So we're going to put our nums and our target. And that's how you define it. It also has to have at least one line. Pass does nothing. Just a way of getting rid of errors. But we already have all the logic written down for most of it. So let's just copy and paste that up here. We're going to fix our spacing. Oh, not destroy it. Oh. All right. So now we have this function and we want to return it. So if we find the answer, we want to return it so we can short circuit. And we don't have to do extra calculations once we find an answer already. So we have to do this in if statement anyway. So if this is true, and notice how inline isn't what we called it here, we called it nums. So we're gonna call this nums instead. If this is true, we want to return a string that looks like this, which is index 1, index 2. That's what we're going to do. We're going to return a string. How we're going to get the numbers. So the indices can be any number. How are we going to make that into a string easily? There's two ways of doing this. You probably worked with just adding strings together. So you'd have to turn these into strings. We'd have to do bracket plus I plus comma plus string of j plus close bracket. That's a lot of, that's pretty simple, but it's just like a lot of typing. There's an easier way you can format strings in Python. We can just say, this will be our string that we format. This is called string formatting, by the way. So we do open bracket, %d. So that's marking that we're going to put a digit there, comma, %d, close bracket. And then after this, we're going to put another %sign. And we put, this is like a function. So we're putting our two parameters here. It'll be I, j. So this will return, if it was 0 and 1, it will return the string with 0 and 1 input there. All right. So we solved the case if we actually found the answer, but what if the answer isn't here? What does it say to do? We'll just say we'll return impossible, right? So we found it, we didn't find it in any of our iterations, the answer to this problem, that the nums that add to target, so it's impossible. Right, so now if we want to use this function, we just call it. We're going to print our answer, that's what we want. We're going to do solve to sum, and we're putting in our inline and our target. All right, so this should work. Let's see if it runs. All right, so doesn't say anything right now, but we need to put in the numbers. And that can be kind of confusing for a user, right? It just seems like it's not working, right? So let's quit this. A nice thing you can do with the input function, you can tell the user what to put into the standard input. So we're going to say, put in, type the space separated list of numbers, and then type the target number. And now if you run this, it'll say, type the space separated list of numbers. If we start doing it, now it looks like, I don't know, it's kind of hard to read. It's concatenated the string. So let's cancel this again. We're going to fix that by doing a new line. New line is the same as any other programming language. See that? So \n. Now we can do this, and now we're going to type in that list of numbers 2, 7, 11, 15. Type in the target of 9, error turn 0, 1. So yeah. All right. How many, does anyone have questions so far?
So awesome. So I don't know. So configure this is just it's very specific. We're going to see oh yeah, maybe restart. Yeah. Which one is it? Nice.
It just won't.
Well, right.
It gets here and then it just restarts. And it was working. It was working.
It's like-
For a long time.
Does it emulate it?
It was.
Does like the emulator run?
It's yesterday.
That seems to be the problem.
No, but it wasn't like the emulator was up, like this was working, but it wasn't even running on the day before that. It was but
Okay.
that was before I installed it.
Which APIs are you using?
Okay, download each new. Okay, download Firebase and each new. Because I didn't know what's wrong.
Okay.
But I can only do it.
But I know Firebase is
I need Firebase.
complicated.
Yeah. That's why I download Firebase, but I still like HTML code in here, just because I know HTML like figured like I don't even know how to use it. Really fast start.
Right. That seems kind of correct. I would say maybe get rid of Firebase, but disable those things until and see if that's like truly a problem.
But the thing is, I was like I like watched all the YouTube videos, I was like kind of racing with right now, like I don't even know where to trace back.
Yeah, so what you've done, it should be version. Because, so, say you say you have a working version, you push that to GitHub, and you have that like commit, and now it's broken, you can put it back to
I did that before, now I know.
that. But what you can do now, what you do with Rail is the main thing with Dart is constant. Yeah. So if you just remove those and then do git or yeah. But that's how to just get rid of things until it works. So then you have to like change your actual Dart to it as well.
That's why I have not.
Nice.
I don't know if it's running, but I'm just wondering why there's so many like errors.
This is bigger.
One bad.
It's a lot.
I don't know why it's so bad. I heard that from them. Way harder.
I think it still is the Java. Try to restart it.
Yeah. Never. Oh, yeah. Oh, really? Oh. Because I guess it's like.
All right, so what I'm gonna do. You don't have that version. Everyone that was working on it, push that thing to a new version. I'm gonna say it though. Yes. Terminal. Make sure so in your workshop, you could run this by doing Python 3 and you name the file. So workshop. So this should be intended to be inside the function. This whole. Yeah. And then it's that first one. No. Vision set. All right. So maybe that would. Yeah, so this will, yeah, once the configuration is set up, it'll tell you. Yeah, that's a good question. Maybe that's extra.
Why didn't this tell me this before?
Yeah, it's because the interpreters are set up. That's the effective. Yeah, no, no returns.
It's a little much.
And the non-returns with unattended. Yeah. This is unattended.
I don't like this. Oh,
Just
well,
like-
yours is, yours is, at the same level.
Everybody just generally saying that we should include the kids. That was fine, or.
And auto.
That's also the words.
This weekend, because I have a really
Thanks.
exciting-
I'm just gonna say I can't run because I'm not.
Alright.
I literally don't have a job.
I'm not going to.
Yes, I think I might have. You might need to check your email. Yeah, make sure you run it though. Yeah. All right. So yeah, everyone, wherever you're at right now, save your progress and make your branch. I'll show you how to do that real quick on GitHub desktop. So this is the history, but if we go back to changes, they're not there, of course. Where are they? Huh. Nice. Let me figure out where this is. I know why. So useful thing you can see in VS Code. On the left side, there's like little bars. So blue means I've edited that line since the last commit. Green means I've added that line. And so forth. I'm pretty sure that's what it might be the other way around, but we'll see if we go on the GitHub desktop, the real changes. So these are all the changes I made. I added a lot of lines and I changed some lines, I deleted some lines. So I don't want to push this to the main branch. I want to make a new branch because if I push this to main and that wasn't working, then it'd be broken for everyone else. So what I'm going to do is I went to this current branch dropdown. I don't have a branch yet, so I'm going to click new branch. I'm going to say Drew Dev. And I'm going to create that branch. And then because I have these changes, it's asking me, do I want to stash my changes on the main branch? Or do I want these changes on the new branch? And I want these changes with a new branch. So now I've created this new branch, but now it's only on my computer. GitHub only knows about it. Git only knows about it on my computer. If we go to GitHub, it doesn't exist yet. And then what we're going to do, we're going to publish this branch. That's how GitHub knows I just made a branch. So now if we go to GitHub, we refresh. Other people may want too, but I had made this branch and it still is not updated with my new code. If we go onto it, we'll see just says workshop code.py. Right. So, and that doesn't have my new changes. So now I'm going to go back here. And now I'm going to say I implemented toSum with double for loop. And I can write more comments, but I don't really need to, because that's kind of saying what I did. So I commit. So I committed, it's local. Again, I have to push it to GitHub. And now if we go back to GitHub, we'll see it's now one commit ahead, one commit behind main. And now we have those changes I made. And now if you guys go on your interface, you would see you could go to anyone else's branch from here. And just as a word of caution, Amanda, you push the main. And honestly, there should be protections against pushing the main. So you aren't like able to do that. But I will show you real quick. You can't do that on a free account. I'm trying to find it. I have it on my other account. Branch, it's called branch protection rules. Oh, I can do this. So I'm going to make a branch protection rule to prevent anyone from breaking the main branch. And we're going to require a pull request before merging. And we require one approval. And that's it. Yeah. So anyone that pushes to merges into a main has to have that approved. So let's say Amanda's code was broken and we don't want her code on main. What we're going to do is we're going to revert that commit. So now we're going to go here. Do you have it on your own branch before I revert it? All right. You would be able to get it later, but it's a bit more work later. So yeah, make sure, let's just double check. Yeah, make sure you make a new branch. Here it is. Looks like it has, yes, your new code. So we're going to revert mainline. How we do that? So we're looking at this, and there's no clear way of doing it here. So we go back to GitHub Desktop, and right now I'm on my personal branch, Drew Dev. I'm going to switch back to the main branch. So I just checked out the main branch, and now you can see, fun fact, if we just went back to my code, it now has Amanda's code here. So let's say we didn't want this. We right click it here. You can do this in the command line as well, but let's say we want to revert changes in the commit. Now it's reverting it. What did that just do? It deletes everything that was added and it adds everything that was deleted. So see how this had the original commit had lots of additions and one deletion. This does the exact opposite. Then we push this and let's go. It requires one reviewer because it has branch protection rules. So how do we address this? Let's see. If we go onto the main thing, on the main branch, so we still have this original commit. This is where you might need to open up the command prompt. So we're ahead by one, git push. Oh boy. All right, so this is also refusing it. So this is kind of what we want to happen. We don't want to directly edit main at all because we want to review it anytime we change it. So now we're going to go to Amanda's branch has that change. And before, okay, there's a few ways to do this. This is why I should have set up branch protection rules beforehand. This is kind of like a weird situation where Amanda will lose her work if I revert it on her branch. So on this one case, I'm going to have to make a new branch. So I just undid that revert on the main branch so I don't have to deal with it. And then let's say I just didn't want that change at all, I would discard those changes. that will delete anything I just did, which was the revert. So now we're gonna make a new branch based off of Amanda's branch. So we're gonna make a new branch. And this will be a really temporary one, so it's gonna be revert change. Oh, so I didn't base that off of Amanda's branch, so I have to get rid of this branch because I did it wrong. So this wasn't published on GitHub yet, so it's just local. So now doing the same thing, revert change. God. Nice. Okay. Let me figure out how to do this properly. Go to Amanda's. Then I based off this. Yes. So I'm making this new branch based off Amanda's branch. Now I'm going to publish it. Now I'm going to revert this change. Now I'm going to push it. And then I'm going to do a pull request into main. So this is like a merge request. I'm merging that new change of the revert into main. I'm going to create this pull request. And now someone else has to review it. Who wants to review it? I'm not allowed to do it. Okay. Amanda, you're going to be the So if you go to pull requests on GitHub, you can deny the pull request or you can accept it. And then now, let's see what that did. So this is all like done to prevent like you from breaking main. All these, or just making sure you write good code in general. So now, set a comment. I think you have to do like a full review. So Amanda had to approve it on her end, and now we're allowed to make this change, and we can now merge it. Now we reverted it. And now mainline has the original code. And let's try to, first, everyone needs to update their branch. Because we made those changes, if you have an old version, you have to update it. You would do branch, update from main. This is not the right branch. I'm going to delete this one because it's already been done. So yeah, update this from main. And now I have a conflict, which is awesome. So now we're going to view this in Visual Studio Code. So what's the difference here? All right. So let's see. So my local changes are in the bottom here. You can tell that It's hard to tell that. Well, no, my local changes are on the top here. Because I wrote this function and it's a current change. And I'm trying to update from the top or main line, which is up there. But you can notice this is where I believe fetching, I did not fetch first. So I think this is where the problem's coming in. Because this isn't what it should look like. So I'm gonna abort this merge. And I'm gonna fetch. And let's see if that did anything. Probably not. Oh, it did. So that's where fetching comes in. It had Amanda's old code in there before I fetched it. And now I successfully updated for main. If we go on the GitHub interface on my branch, it's now 2 commits ahead of main because I did my code plus the merge code. All right. Now, does everyone want to make a pull request and try to put it into main? Or we can call it quits because it's also been really long. I'm down to stay for a bit, but you guys are free to go because this is long. Yeah, well, let's call it quits. But if you wanted to make a pull request, you'd commit your changes and you could do pull request here, or you could do it from the online interface. We go to my branch and we would do pull requests, new pull request. And that's how you do it. All right.